Have you ever noticed that videos on websites like YouTube load faster and more smoothly compared to videos on other websites? This is due to a technology called Content Delivery Network, in short CDN. In this video, we'll explore what CDN is, how it works with an example of a user typing www.youtube.com into the browser, and I hope this will enable you to confidently integrate CDN in your system design architecture. So, let's begin. CDN is a system of servers located in different parts of the world that work together to deliver content to your device faster and more efficiently. This helps websites and online applications deliver their content quickly to users all over the world, even if they are located far away from the website server. For example, if a user is in New York wants to access a website hosted in London, the CDN would select a server located in New York to deliver the content to the user. This would ensure that the content is delivered quickly and efficiently, as the users would only have to connect to the server located close to them. CDN is important because it not only helps websites and online applications deliver their content quickly, but another benefit of CDN is that it helps to reduce the load on the website server, as the content is delivered from multiple servers located in different parts of the world. This ensures that the website remains available and responsive even during periods of high traffic. Let's go through a simplified explanation of how CDN works when a user types say www.youtube.com into the browser. So here we have a user who types youtube.com into their browser. The browser sends a request to DNS resolver, which basically looks up the IP address associated with youtube.com. Details of how DNS is resolved is not needed for our purpose, but at a high level, if YouTube did not use CDN, their DNS server would have returned the IP address of youtube.com. But with DNS configured, YouTube will have an alias pointing to www.youtube.cdn.com. That is the domain name of YouTube's CDN server. The DNS resolver returns the IP address of the CDN load balancer to the user's web browser. The user's web browser sends a request to the CDN load balancer for the content associated with youtube.com. The CDN load balancer receives the request and uses a load balancing algorithm to select the best CDN edge server to handle the request. This is typically based on factors such as location of the user, the capacity of the edge server, and amount of traffic on the network. By the way, a CDN edge server is a server located at the edge of a content delivery network. The edge here refers to the physical location of the CDN server or data center that is closest to the end user. The user's request is then routed to the closest CDN edge server based on their location. The CDN edge server checks its cache for the requested content. If it is not there, it sends a request to the origin server. The CDN edge server stores a copy of the content in its cache and sends the content back to the user's web browser. And again, the origin server here is basically the primary source of website's content. It is the main server where a website's content is stored and served from. And finally, the user's web browser displays the content to the user. The CDN edge locations are organized in a hierarchical network, with the edge servers at the bottom of the hierarchy connected to a tier of intermediate servers and ultimately to a central origin server. This hierarchy helps to ensure that the content can be delivered quickly and efficiently, even during periods of high traffic or server load. At the top of the hierarchy is the central origin server, which is the main source of the content for the CDN. This server is responsible for generating and storing the original version of the content, which is then distributed to the edge servers. The origin server is typically located in a data center, where it can be easily managed and maintained by the CDN provider. The intermediate servers, also known as regional servers, are located between the edge servers and the origin server. These servers help to manage the flow of traffic between the edge servers and the origin servers and ensure that content is being distributed efficiently. The CDN edge servers are located at the bottom of the hierarchy and are responsible for caching and delivering content to end users. These servers are spread out across different geographic regions and are designed to handle a high volume of traffic. By caching content at the edge servers, CDNs can reduce the amount of traffic that needs to be sent back to the origin server, which helps to reduce latency and improve the overall performance of the CDN. Now there are many different CDN providers available, each with their own pros and cons. Amazon, CloudFront, and Akamai are the popular options. Fastly is another CDN provider that is known for its focus on performance and its ability to handle high volumes of traffic. Cloudflare is a relatively low-cost option which is easier to use, but its network is not as large as some of the other providers. Max CDN is probably the most cost-effective option and also user-friendly features. However, it also has a relatively small network of edge locations and has a limited range of advanced features compared to some other CDN providers. Now, in a system design interview, the importance of CDN might be discussed in terms of its ability to improve performance and reduce latency, its ability to handle large volumes of traffic, and its ability to improve reliability and reduce downtime. Your interviewer will not likely ask about the specific features and capabilities of different CDN, but it's good to know some of the popular CDN. Overall, CDN is an important technology to consider in system design interview, as it can help to address many of the performance and reliability challenges that are common in large-scale online applications. By understanding the basics of CDN and how CDN works, you can confidently integrate it into your system design. In fact, you will find me using that in my future system design videos heavily.